Hi, Dr. Sneath.
Hey, Charles, how's it going?
Good. So listen, it's Sneath.
Sneath, that's right. Yes,
not sneak.
Not sneak, not sneeze, not snorts, nothing else like that. It's
Dr. Sneath.
Sneath.
So what are we doing today? We're in Building 10 yet again.
Building 10. Once again, anybody who's been watching these videos for a while will know that we sort of start these videos with about 5 minutes of me randomly wandering around.
Figuring out who we're going to talk to.
Well, we kind of figured who we're going to talk to. We're going to chat with Rob Relyea, who's one of the kind of architects behind XAML. And he's going to kind of talk to us hopefully a little bit about where XAML fits in, how people use XAML to build applications, what really goes on under the scenes when you actually take a bit of code and how that gets compiled. What happens to XAML? Does it become C# or does it get bound in something else? So we'll talk about a few of those different things and
how. The history of designing it and stuff like that?
Yeah, exactly that. That's kind of the goal.
Good.
So we're just kind of randomly wandering around at the moment.
There's the cool egg.
There's the cool egg again. We're wandering past Peggy.
Very nice.
Peggy,
How's it going?
Hey.
Hey.
How you doing?
Cheers.
Cheers. She was on C9 not too long ago.
She was, yeah. We did one on WPF imaging, and that's an interesting topic. And we're nearly there. This is like a tour of all our old homes. There's Greg Shaker.
Great. So he didn't tell you about the interview that we're doing with you today?
That's right.
Yeah, we're gonna. So we're gonna talk about the architecture of IE.
I'm all on it.
All right. Hey.
Where you guys headed?
Do you know where Rob Relylea's office is?
That way.
Excellent.
Keep on going.
Nice to see you.
Best of luck.
Thanks.
Keep up at the back there. So we're nearly there. I told you this one was going to be a long walk.
That's fine. This was fun.
We're here. This is Rob's office.
All right.
How are you doing, Rob? You're on Channel 9.
Doing great.
All right.
Good. So we just thought we'd come down.
You brought me a drink.
Yeah.
We've all brought our
Well, I don't have any germs. Help yourself.
We're cool.
Hey, how are you doing?
Hey,
Charles, Channel 9.
There we go. Cool. So, Rob, tell us a little bit about yourself. Who the heck are you?
So I'm a program manager on the WPF team, on the Avalon team. I work on Avalon. I work on XAML. I work with the CIDR team, the Sparkle team, to make sure we have great tooling for WPF.
Cool. How long have you been working on Avalon?
Since, I think somebody said that January 17th, my mom's birthday of 2001, is when the team was officially formed.
Right.
And I was there,
you were there
before then, yeah.
Even before the team was started. Before the team was, you were.
Yep.
There we go. So just tell us a little bit about XAML specifically. How did we come up with this idea of using XAML and XML? When we started, we've chatted with Michael Wallant and Greg Shaker about architecture and about the genesis of the team, and why did we build this XAML thing in the first place? Why not just stick with code like WinForms does it?
Right. Well, we had a bunch of the team coming over from working on Trident on the rendering engine for DHTML. That's where I came from. So we definitely knew that markup was a key part of any UI platform, and we needed to really update Windows to leverage markup, and I think we found that you're able to have a bunch of different tools contribute and all participate in the ecosystem dealing with XAML,
right?
Which is going to help everybody.
So this notion of XML as a way to express the content of a series of classes, basically.
Sure. At first you saw we went ahead and expressed normal things as markup and just object instantiation. But what we actually did in Avalon is we also started modeling a lot more things declaratively. Once we started down the declarative path, we kind of said, well, why couldn't we do this declaratively?
Right.
Often you see people in forums, internally or externally, saying, well, yeah, I could do this in code, but I'd really like it to do it declaratively.
Right.
And I think once they start there, they want to do it there. It's got the great benefit of once you're there, you can have tools that don't need to know how to parse C# or VB or other, or JavaScript, those kind of things. You can have a variety of tools deal with these concepts and provide great tooling,
right,
great capabilities on top of those things. So property setters, for instance, or event setters, those types of concepts in our style system instead of having code when you mouse over something and having to have code change properties based on that, we were able to generically go ahead and say, well, a property setter goes ahead and says, well, when something is true, then set a variety, a bunch of other properties, property triggers. I'm sorry.
Right.
Interesting.
Right. Yeah, I think one of the things I love about XAML is the way that it's very, very expressive. You know, in a short amount of time, you can put together something that would actually be, you know, just a ton of rather dull code to write, but actually wouldn't. You know, you'd have more lines of code. It wouldn't look as easy to kind of parse visually, but it's actually something that's a very expressive way of just building something like a UI.
Right. It does a great job of capturing hierarchy, of expressing the minimal things that you need to go ahead and set. What properties do you want to set? How do you want to change the default behavior?
Right.
How are objects related? And allow you to wire together pretty functional things. And then because this is all XML, that allows you to tie into the XML ecosystem, and that, you know, XLT and XML editors and transform
Web services.
Web services, absolutely. Get your data as XML, get your data other ways, and visualize it in great ways.
Right.
Great.
So I know that, I mean, the way that one uses XAML, you write some XAML code, or you use something like Expression or Cider, Visual Studio's Designer to create your UI, and then often there'll be some C# or some Visual Basic code that kind of goes alongside that sort of sits in the background, that it sort of perhaps is the event handlers or other elements that kind of glues the XAML to the rest of the system. Can you just sort of talk through a little bit, perhaps, just how XAML kind of integrates into the kind of compilation kind of stage? I mean, what happens to XAML? I know it's changed a little bit over the years,
Right.
but can you just describe, what happens as you start with XAML and go to an executable?
Sure. So the default scenario when you go ahead and add a new page or a new window into your project, whether you're in VS or Expression or other tools, is that you're going to end up compiling that XAML. So and you end up compiling that into two things. You take all the object tree and all the property sets, and you convert that into what we call BAML. BAML is a binary stream that has pre-tokenized all of the information in the XAML. So it's going to be quicker to load the BAML file than it was to load the XAML file.
Right.
And then we also go ahead and generate a generated code file, and we call it like a .g.cs file for generated, or .g.vb file. And that code is going to do the event wire up. So if you said button click equals foo, it would go ahead and wire that foo to the button for the click event. It will also go ahead and make it so that if you had any named elements inside of the XAML, it will make it so that code knows how to address it. So for every name you have inside of a XAML file, the code is going to go ahead and create a field for it, button 1 of type button.
Right. So
then now you can go ahead and just refer to things as button 1.
Right.
So we've integrated into the MS Build system. MS Build came with .NET 2.0. It ships in the framework, and Visual Studio takes advantage of it. But the great thing about MS Build is that now all of a sudden you have a command line tool that you can go ahead and build projects, and you can also go ahead and build them in tools like Visual Studio. So you don't need to have a separate SDK sample that will work from the command line and those that will work in the tool.
Right.
So 3 or 4 years ago, we had our own compilers, and then MS Build came along, and we basically tried to figure out how do we plug into the MS Build system. So you build tasks, and we have a markup compile pass 1 and a markup compile pass 2 that basically end up sandwiching the core compile stage, where CSC or VBC is going to go ahead and compile the code.
Right.
And we run through, and basically we need 2 passes. In markup compile pass 1, we walk through, we go ahead and create the BAML for all the pages that we can, and create the code behind files, the generated code. Then we'll go ahead and build the assembly using CSC. And some of those XAML files actually referred to things that weren't yet built until we built the executable.
Right.
We call those locally defined classes or components. So we need to go ahead and create those, basically go check and perhaps recreate those BAML files for those files in markup compile pass 2.
So it'd be like something like a reference, or
Yeah, if I went ahead and built my custom button, I could go ahead and put that into another DLL, or I could go put it into my application itself.
Right.
And if it was in the application itself that the XAML's inside of, it needed to go. It's basically kind of a self-referential thing. And
Right.
whenever we see XAML, normally what we're doing is we're reflecting on the assemblies. If you refer to something from Presentation Framework button, we'll go find it and we'll go encode that information in the BAML of exactly what class we found and what properties, and we'll validate it and basically try to fire some compile errors.
Right.
So we're just carrying that further.
Right. So this BAML then, is it literally a one-to-one tokenized representation of the XAML, or do you do any further kind of optimizations? Is it an opaque format?
So we've basically stripped out any code you have. So if you put code in line inside of a XAML, not many people do that, but it's possible.
Right.
It takes Xcode and code out. It also takes all the event handlers out, and it leaves the object settings and the properties. And it sometimes converts. There's several different syntaxes you can go ahead and use to set a property value using XAML. Sometimes we'll go ahead and in the BAML, it didn't matter if you used attribute syntax or property element syntax to set the background property, and the BAML might end up the same.
Right.
But we'll go ahead and the basic concept is when we go ahead and have 3 buttons inside of a XAML file. In the BAML file, we'll go ahead and have one record that says, oh, there's a type called button. It's system.windows.button from this assembly number. And then when we want to go ahead and instantiate these different buttons, we say, oh, well, go use type number 44, which happened to be the button class.
Right.
And so it's just trying to be, how can we be as fast as possible at runtime, but still allow you to use XML as a source file. So our goal is to not use system.xml at runtime.
Right.
We're built on top of the XML reader infrastructure inside of system.xml when we do XAML parsing, and so our compiler uses that. And at runtime, if you want, you can go ahead and parse XAML as well, and then you'll load system.xml. You'll use the XML reader, and you'll use our runtime parser.
And the case where you want to parse XAML at runtime is if I wanted to dynamically change my UI.
Sure, if you wanted to dynamically change the UI, although.
So when would I do that? When would be an example of runtime?
Well, a lot of times the UI doesn't. Well, the basic idea in the web today, most people have server-generated UI plus data intertwined, and Ajax is showing people that they shouldn't intertwine those things, but instead they should be able to go get their data on the fly and update the UI as it goes.
Okay.
So oftentimes, XAML can represent data, or XAML can be UI, and there might be you might have something that's data driven, or customers want to go ahead and customize an existing form and add additional things, and so then you'll want to go ahead and use it at runtime. Or you might be getting content from from a central site. So New York Times, for example, you've seen the demo of the reader that does great newspaper reading with New York Times, and they're able to go ahead and send data down, whether it's XML over the wire and then conversion into XAML on the fly, or they could send the XAML over the wire. There's a variety of ways to go ahead and make sure that fresh content is available.
Very cool.
Right. So we've talked through the process of XAML being converted to BAML, and the process of a markup, two-phase kind of markup compilation sort of process that also creates its generated C# or Visual Basic file. And that's like, so if you've got like a class of, say, window in your XAML, what exactly are you going to see in your .g.cs file? Is that actually going to be called window or window
Sure.
1?
Maybe I can. You want me to whiteboard for a second?
Yeah.
Okay. So let's just talk about the 3 different files that most people are going to have and talk a little bit about that. So let's pretend you've got, in your default project, you go ahead and have a window1.xaml. And then you also have a window1.xaml.cs. And then we will generate for you a window1.g.cs. So let's talk about those different things.
Okay.
So at the root of every XAML file, you go ahead and just have a class, and basically every tag ends up mapping to an object of some sort. So you look for a type in the .NET runtime. The way we find that is we go ahead and use XML namespaces. So you go ahead and say XMLNS, and I'll kind of skip this. This is schemas.microsoft.com, WinFX 2006, XAML presentation, let's just say. So those give you all of Avalon's types. And although we're a .NET class library that has factored a bunch of types into nice namespaces, system.windows, system.windows.controls, system.windows.documents, media, etc. got a bunch of those. We try to make it so that the markup author doesn't need to, the markup author and tools don't need to concern themselves with exactly which CLR namespaces all those things might logically fit into.
Right.
So, so basically, window, button, grid, all those types of things are findable by looking here, and we can go into depth of how that's done in a minute, if you'd like. We also have another namespace that is the XAML namespace, and people usually use XMLS:(X), and then they go ahead and use the same URI except just XAML at the end, not XAML presentation. And this is kind of the URI that defines the XAML language and just all the XAML concept itself. So in this model where we're actually building and compiling a XAML file, you end up building a class. We talked about generating the C#.
Right.
So you need to go ahead and give us a clue of what class you'd like to build. So you go ahead and use x:class up on the root element. And I think by default, if I had some project name, it would go ahead and instead of a C# file, be project name, whatever that is, dot window1 perhaps. So that maps over towards here in your code behind file that's going to be created. You're going to have, if this was C#, you'd have a namespace called project, and then you'd have a
Class.
there we go. I'm used to IntelliSense here.
Sure.
You'd have a
See,
You have IntelliSense on your whiteboard. Wow.
Yeah. See, that's what's happening.
I'm waiting for that.
IntelliSense happens. Okay.
So we'd have public partial class window1. So we're building the new window1 class, and we're extending window. We're subclassing window. So over here in the XAML file, this is your base class. The root element is your base class, and this is your new class. And so you go ahead and define the same class over in your code behind, and actually the generated C# file that we're going to end up creating is going to be the exact same structure here. It's going to be a partial class called window1, subclassing window in the same namespace. So we'll put some code in here that does the eventing, and we'll do the name the name wiring. And then you'll go ahead and put code here. You'll do a handler like public void on click. Sorry. You'll put in a few things inside of here, and then you'll be able to go ahead and say button1.content equals hi. So let's go back over here and just say, well, if I wanted to just put a simple little button inside of here, I'd go ahead and say button, and I'd give it a name of button1. And then I could go ahead and wire up a click event. Click equals, and I called the method on click over in that code behind file. So this is a close to minimal hello world in XAML on the way. But that was your question about class and how does that
Right,
mean? So,
right, exactly that, yeah. So that XAML then at runtime gets turned into a .baml file, which is stored in the same object directory as this .gcs.
Yeah, so we go ahead and take all the C# files in the project, the code behind files, the generated C# files, and other C# files that you might have had in your project, and we'll go ahead and put that into the executable, and as you know in .NET that all gets compiled into IL in your immediate language, and then the BAML file, the BAML representation, basically gets stuck in a resources section down here. So we'll go ahead and have window1.baml down there somewhere, along with foo.jpg and other files that you want to include with your executable. And when you go ahead and want to launch this window, you can effectively usually go navigate to it via its URI, window1.xaml perhaps, or you could also go ahead and just programmatically say new window1, and it would then launch up. And
so those guys get jitted together? So you put the BAML down there.
Yeah, put the BAML inside of there, and so it goes out when you go ahead and build myapplication.exe. It's inside. It's compiled inside.
IL.
Well,
no.
The BAML is just like a file, a JPEG. So it's if in .NET 10.20 you have .resx files that get compiled into .resources.
Got it.
And so this is inside of a resource block.
Right.
Okay.
And so that gets then loaded by window1.g.cs. There's a line in there somewhere that loads BAML up.
Right. There's a constructor inside of window1.g.cs. Actually, there's a constructor over here that calls initialize component. Initialize component knows how to go ahead and load the BAML.
Okay.
It loads it up, and basically, this BAML. Let's just go ahead and pretend we can show you what the BAML would look like for this. Effectively, it would be we go through this and we find the window class and we say, oh well, we got a new type. And before we say that, we have a new assembly. So we go ahead and say, oh, we got this assembly number 1, and assembly number 1 is presentation framework.dll. And then we say, oh, and we got this new type, so let's go ahead and keep track of the type called system.windows.window, and we'll call that type number 1. And then let's go ahead and instantiate type number 1, which is from assembly number 1. And it's got no properties on it. Then go ahead and define another type, number 2, which is the button, and instantiate that button, which is type number 2. And then you have the property of name being set to button 1. So this turns into a list of assemblies of types and instructions to go ahead and instantiate those types and set properties. And as that gets parsed in, basically there's callbacks to this code. Whenever we see something with a name inside of it, we'll go wire the event or go wire that field.
Right.
Now, did we cover earlier, did you go over earlier why the need for BAML? For example, why isn't IL enough? Right? You have the source file. It gets compiled to IL. Why do you need a binary resource that contains that information?
So we liked the name so much. Actually, after PDC 2003,
it is a cool name.
Somebody blogged out there, XAML BAML baby with names like this. How can it lose? It's
all right.
Best technology name since SCSI. So I like the ring of them. But so actually, what we did a couple years ago, we did have the ability to compile all into IL, and so your tree here, your tree definition would be converted into new button, new this, new that, set this property. So we had these 2 code paths, and actually what we were able to do with BAML is we figured that BAML was a better way to go because it's easier it fits better with our localization strategy. It's easier, it leads to smaller executables as well, because it's a lot easier. Basically, the IL representation of all this code would be larger, and so download size of applications and DLLs would be larger. So there are a bunch of pros and cons that we looked at.
Sure.
And we thought actually we had the all IL for performance reasons, but it turned out that BAML was, at that point, 95% as fast.
Okay.
And so if we went and just put more optimizations there, we effectively could go get the same perf.
But now, speaking of which, so if you have sort of a your compile time or runtime making change optimizations, which is what the jitter does, can't do that for you in your BAML. You know what I'm saying? So you're doing all the optimization on the front end.
Just like the C# compiler may do some optimizations when it creates the IL, but it also is able to go ahead and do some things at runtime. Perhaps I don't know as much about jitting, but yes, we're not able to do as many tricks.
Okay.
Or we haven't yet invented new tricks that we can do at BAML at runtime.
But this isn't like random code, like
I understand.
Like when you're doing C#, of course, because this is just pretty much a representation of the structure of the objects, right? I guess so. So it's pretty straightforward. It's just an iterative process to load this BAML stream in at runtime, right? It's not a major sort of complex compilation process that you're undergoing there. You're just laying these things out.
Once we have those instructions, it's a very, very quick way to just go ahead.
Right.
Great.
I guess the downside is it's harder to debug, right? Because in the past, if you had an error in the XAML, you'd know about it at compile time as part of the GCS file.
So that's clearly an issue. We've got 3 different places where we can go improve XAML debugging. There's kind of the design time. So design time, basically having expression, having CIDR go ahead and have a great experience for creating, doing form design, etc. That's going to mean that you have compilable XAML.
Right.
then there's also the XML editing angle of those things, right? When you go in there and natively go ahead and edit. Today we have IntelliSense based on a schema, which isn't perfect. I write the tool that machine generates that schema. And it's not perfect because XAML, not all things in XAML can be expressed as XXD. So, and plus, I could do a better job as well. But longer term, the VS team is going to be building, they're planning on building better editing services that natively know about XAML, not just XML. And so love to work with any third parties to go make that happen as well. So there's design time, there's compile time, and then there's runtime. And at compile time, we don't do a phenomenal job of catching every error right now. We can continue to improve that beyond where we've done in V1. And part of the problem there is sometimes we need to go ahead and run type converters and other things like that to understand if an attribute value is valid or not. So with that, the Windows Build Lab and other folks don't like code running in the middle of a build. It leads to a fragile build process. So we're trying to do as much of that as we can in V1, and we'll continue to invest in making our compiler catch more and more errors. And at runtime today, we can throw up an exception with the best of them. Unfortunately, we don't tell you enough information. Now I assume this is going to be, Beta 2 is likely out by the time everybody's seeing this thing. So Beta 2, hopefully we've made some improvements. We've made improvements, and we've invested in improving error messages, etc.
Right.
But we don't have the major win that we already, we've got checked in already, but it didn't make the Beta 2 cutoff. So what we're doing now is we're putting more information inside the BAML, including line numbers and offsets.
Excellent.
So tools will be able to catch those exceptions with more information and then go to the right place.
Right.
So what we'll do is we'll do that at debug mode only. We'll go add some line numbers and then
So
you'll
the kind
get a
of
better
thing you get
experience.
sometimes today where it just says there's an error has occurred with, say, a grid element or a button element, and there could be 1,000 of those in your XAML file to trawl through just speculatively. Those things will be much easier in the
Right.
future.
And I believe in Beta 2 we've got the change in there so that if you have an ID or a UID on an element, we'll actually tell you that too. So we're trying to do better.
Okay.
And you'll see much better in by the time V1 ships there.
Right. Now, you were talking as you were describing the XAML file here about the use of namespaces here to scope references to these various objects from within various different namespaces or assemblies. Can you describe a little bit more about how that's done? Because that kind of impinges also on the extensibility model, right?
Sure. So, as I said earlier, we have two main flavors of namespaces. We have the schemas.microsoft.com, I'll go ahead and schemas.microsoft.com's WinFX 2006 XAML. That was the language. And then we had the XAML / presentation. This one maps to, if you go ahead and look at our assemblies, we have assembly level attributes called XML&S definition. And what we've done is we've gone ahead and said, hey, that URI /XAML / presentation maps to a set of CLR namespaces. So system.windows, and you go ahead and have a set of these things. You go ahead and basically go ahead and say, oh yes, XAML presentation also maps to system.windows.controls. So we've statically, we've declared in a way that anybody can statically understand. Tools can statically understand. Well, when I mention XAML / presentation, I can go ahead and look in these 3 different assemblies in one of these 10 different namespaces and find something.
Right.
So there's obviously guidelines to make sure within these namespaces you've grouped together into an XML namespace. You can't have any overlap of type names because we're not going to exhaustively search through every single namespace and tell you about that. So those are guidelines that FXCOP will say enforce in the future. And so that's one way to go ahead and do it. Is when you're going to go ahead and build a library of components and you want a real great URI, that's one thing you can do. And then you can also go ahead and just in namespaces, oftentimes you want to refer to something, say in the system namespace or something like that. You can go ahead and define a new prefix, and we killed off the mapping PI. and replaced it in, I think, the February CTP with this new namespace URI, CLR-namespace : and you go ahead and say the system namespace, and you say what assembly it's from. So you say assembly equals MS core lib. And so that's going to go ahead and let you now go ahead and express date time, for instance, the date time object in XAML, where I can go ahead and express a date time. So that's definitely been one of the changes of XAML over the last year or two. Chuck Jasky joined the team and was an architect working on XAML. He's also on the CIDR team right now. And Chuck helped influence us to become more and more generic. Much like C# or Visual Basic deal with types in a generic way, XAML, we've basically tried to get rid of any Avalon-specific things in the XAML language, and we've tried to make it work very generically. So we use interfaces, we use attributes, whether they exist already, like type converter attribute, or we invent new ones, like XML definition attribute. And we use those types of things that compilers, tools, everybody can go ahead and understand, and people can go ahead and express how their type should be represented in markup.
Right. So
Excellent.
in theory, you could use XAML against something that wasn't WPF.
Absolutely. I'm starting to look a lot at just representing general data as XAML, and so you've seen the Windows Workflow team go ahead and do XAML,
Right.
and so they have activities and workflows. You probably go deeper there than I do, but I've worked with them. Maybe not. I've worked with them a lot on the XAML side of things, and we've gotten to where we're pretty much the same set of basic rules. So when somebody's building a type, whether they're building a control for WPF or an activity for workflow, they're able to go ahead and still have a markup representation, and we're following the same rules. Now, unfortunately, we have more XAML parsers and compilers around than we'd like to. Due to schedule problems, schedule constraints. Workflow has one, and we have one.
Right.
Our tools, CIDR and Sparkle, they have. CIDR and Expression Interactive Designer, they have their own parsers as well. So, rallying around a specification of this is what the language should be has been important. CIDR and Expression, it's really important for them. They went ahead and wrote their own parsers, not because our parser was bad, but because their users have different needs.
Yep.
I don't know if you remember Front Page 1.0. When people used Front Page early on, and then they went ahead and used the designer and then went back to the markup view, oftentimes it would munge your markup and it wouldn't leave
Yes.
it alone. You'd lose your white spacing, it might change ordering of attributes. It's been so long I don't remember. But
Oh, you're right.
Yeah, so
I think 2.0 did the same thing. Maybe even 3.0. Maybe even 4.0.
it took a bunch
All
of
right.
versions. But so the great thing is that both of those teams are working to make sure that people can go ahead and look at, modify, understand, change, and go to the visual designer, but still go back and not have things messed up. It preserves what attributes you had there, where they were, all the white spacing, etc. So that's a great. I'm excited that we've
Right,
gotten that.
right.
Now, but that brings up an interesting point. So that with CIDR, for example, when a designer sends you just a XAML file, is the CIDR parser going to generate the BAML file
So the
for the
CIDR
project?
a
So in other
designer.
words, what I'm saying is, so you
Oh.
give me a bunch of XAML, and I just load it up, and the surface shows up, and I start writing code against it in Visual Studio.
Sure. So the compile phase and the design phase are two different things.
Sure.
So the designer is going to load the XAML up, and they'll keep their own data structures about where was the space and all these things that we shouldn't have to care about at runtime, but things that are critical to their customers. And so they go ahead and they instantiate a tree of objects. They don't do that through BAML at all.
Sure.
And then when you go ahead and draw things, they change the tree model, and then they're able to save it back to XAML. When you press Control-Shift-B, F6, whatever you're going to do to compile, it runs MS Build. And MS Build is running are markup compile pass 1 and markup compile pass 2,
Okay.
which were defined in presentation build task.dll. So whether you're compiling inside of Expression, inside of VS, inside of Borland tools, other people's tools, Mobiform. I don't know if Mobiform does compilation yet. Any of those things, they
Using
will leverage
MS
the same
build.
compiler, the MS build, and the
So
same
multiple
compiler.
parsers potentially, but always one build environment.
Right.
Very cool.
So one thing I'm kind of keen to kind of explore a little bit more, and one of my favourite features of XAML is the concept of attached properties. You know, the idea that again you're not just limited in the way that HTML is, that one thing defines all the properties on itself, and that's the canonical definition of itself, but that you can use things like layout panels to drive and define the elements or properties actually at the child level. Can you just talk through that a little bit more and perhaps whiteboard a little bit more of how that works out?
Should I erase this, or do you want to
You can raise, I think. We've got
can erase.
the
We got
camera
this.
set up that way.
Okay.
Or extend. Extend and embrace.
Yeah. Okay. So let's talk about attached properties. Well, you also talked about maybe getting into the class hierarchy a little bit of WPF.
Right.
I'll start with dependency object and talk about attached properties. So everywhere in all the types in the world that are managed types in .NET framework derive from object, and we've got I believe it's called dispatcher object. I won't go into that one right now. And then a subclass of that is dependency object. And you'll find most of the objects in our world are dependency objects. What dependency object does is it adds our property system. And you might ask, well, why do we need a property system? Because .NET had a property system. They had properties. Well, we wanted to do a bunch of things with properties. We wanted things like styles. We wanted data binding. We wanted animation. We wanted the ability to do things like attach properties. So a bunch of things caused us to want to have additional services for people who define properties. Inheritance is another one of those things. So with February CTP and earlier, if you wanted to go ahead and you were able to do something like this. You could go ahead and use a panel. You mentioned something like doc panel. Have a panel, and then go ahead and put any control inside of there, like button. And we wanted to make this an extensible model. So we wanted to make it so that doc panel, anybody else could go ahead and make their own panel. Your team's gone ahead, I don't know if it was Karsten, went ahead and built the hierarchical view, carousel view control, which is a great one. So you want to go ahead and oftentimes the layout, the panel, wants to be able to go ahead and understand different things about the children. Do you want it to be dock to the left or the right? So what we do is we go ahead and we allow you to go ahead and say doc panel dot doc equals right. And so in addition to being able to set normal properties, you can set these attached properties. And this is, you see a period in there and you know it's something special. So that's one of the places within XAML that we have periods. So this basically means go find the doc panel class and then go look for the doc. We actually implement this much like WinForms did. WinForms had extended providers for tooltips and things like that. We have a static setter called setDoc and a getDoc as well. So when you go ahead and say docPanel.doc, we'll make sure that there's a setDoc or getDoc on the docPanel class. And now, February CTP and earlier, we made sure that happened, but then we went ahead and took a shortcut and we basically used the dependency property-ness of the dependency object and went ahead and set that value under the covers in a fast way. We still do that performance optimization, but now in May CTP, in Beta 2, for the first time, we will actually allow you to go ahead and have attached properties with these just generic setters and getters from any without necessarily having a dependency property backing it.
Okay. So just kind of backing up at least to a high level, perhaps for people who aren't all that sort of familiar with the attached property model, when you do something like button docPanel.doc equals right, you're effectively doing something like, if that doc panel was called docPanel1, you'd be doing something like docPanel1.setDoc button right, button one right, that kind of thing. Is that about right?
Yeah. You would effectively you would be just calling docpanel.setDoc,
Right.
passing in that button instance, comma, doc.write.
Right.
And that value would be stored. The dependency object system allows values that that object didn't even understand to be stored with that button. So now at runtime, when the doc panel is trying to figure out, well, I've got 5 children, how do I go ahead and decide who goes on the left and who goes to the top, etc., it's defined these properties, so it just goes ahead and says, well, I might care about your height and width, which is a centrally defined property, but I also care about this doc property.
Right.
So let me go ahead and call the getDoc method and pass in those objects, and it will go find the appropriate storage and tell me the value.
Right.
So now why not implement that as a doc property on button?
Okay, so we could go ahead and make this a doc property on button. The problem is you end up with a place where you're not very extensible. So we talked about the carousel control before. If somebody wanted to go ahead and make a my carousel, I don't know how to spell it, carousel panel,
Yep.
they couldn't go ahead and define their own new properties on top of these different things. So we wanted to go ahead and make it so that different panels could plug in and ask for their own specific data there.
Understood.
And we also wanted to make sure that any properties set on things always worked. DocPanel.doc kind of gives you the clue that only if a doc panel is your direct parent and is harvesting this property will it do something. But if we had a doc property there, you'd expect to be able to set it anytime and have it have an effect. So this gives you a little bit of a clue that it's not your doing, it's this other object that's going to help.
The other
you.
object's docking you on its surface.
Exactly.
Understood.
So it's the one.
So to come back to the dependency objects one more time, what exactly is a dependency object, and how does that help out from, you were talking about the way that we do it differently in Beta 2?
Sure. So dependency object is just an object that is able to have, it adds a few methods. It adds a set value that takes a dependency property and a value, and it adds a get value that takes a dependency property. And dependency properties are the properties that underneath most of these properties that you see as attached properties, you'll have a dependency property. Most of the normal properties are dependency properties as well. So docpanel.doc actually has a docpanel.doc property field, which is of type dependency property. And so that's kind of the cookie that you pass into the system to say, hey, I've got this property that I might have defined, somebody else might have defined. Please store this under this cookie with this value. And it does storage there, it does change notification, it provides a bunch of services that allow you to go ahead and do styling, data binding, animation, attached properties, inheritance, building all those services on top of that core property system that's been exposed at DO.
So once you've got a dependency object, you can do things like if you've got a data bound property and it changes, you can have it bubble up somehow so that it can be caught as an event, or so a binding can show a change to some UI element, right?
Right. You're able to go ahead and understand, basically the data binding system understands our property system and can data bind to any property. And you point it towards any property in the world, whether it's a DP or not, and you bind it back to a DP, and it keeps it up to sync whenever that changes, and you can animate and do all those things.
Cool.
So we want to make it so that the properties seem like normal properties. So there's still, from code, attached properties are a little different, but from code, most properties, whether they're dependency properties or not, they all work the same. We want to make it so that most people don't need to know that there's a difference, but you know.
Right. So going back up again to the XAML kind of level, we were talking about sort of how XAML is turned into BAML. It's runtime as part of initialized component. It's turned into real sort of elements, and properties are set and things like that. So what else can I do with it at runtime? I mean, can I take some objects and save XAML out from them, or where does XAML and BAML fit in at a runtime level?
Sure. You can take a tree of objects. I guess Microsoft has 6 serialization technologies. XAML is very useful inside of tools for UI and for workflow, and you can also go ahead and serialize. Although I have to say we've done we've put more emphasis on the reading of XAML and instantiating than we have on saving in our first version. So,
Right.
but we have two main classes that you can use at runtime. We've got XAML Reader, and XAML Reader is the class that is the parser, effectively. It used to be called parser, I believe, XAML parser. And you go call XAMLReader.load, and you can go ahead and load in a XAML file. You pass it a stream right now, which is maybe could be easier. But then we also have something called XAML Writer, and XAML Writer .save. I believe it just takes an object, so you can go ahead and have a tree of objects, and pass in this object to XAMLWriter.save, and it will
like a window or something like that.
Yeah, it could be a window, it could be an auction item, a business object. It could be whatever you wanted it to be.
Right.
You could go serialize that as XAML. And there are rules to designing classes that are going to be able to be loadable and savable as XAML.
Let me guess, they need to be serializable.
Well, it's not exactly. We
Okay.
don't require that you mark yourself as, I don't know, iSerializable, but we make sure that you basically need to have public properties. We'll serialize only public properties. We don't try to go ahead and guess internal state. So if it's not settable via public OM, we can't serialize it. We make sure that you are creatable, you have a default constructor. Or there's alternate mechanisms. Some folks don't have a default constructor, but they have a type converter that can be used to create things. And then for serialization, when you have collection properties, you should go ahead and mark those properties as designer serialization visibility content. And if you want to hide something, you can hide it using .hidden and things like that. So you can control the serialization of your objects as XAML using those different rules.
Right.
One major thing that people often need to learn about is the content property attribute. So if you look at XAML, and pretty much in XAML everything's either an object or a property. Plus event handlers in the compile case. But you have objects and properties. So if you go ahead and if in our case here we've got a dock panel with two buttons inside of it, and I'll erase some of this so you can read it, but you've got a dock panel with two buttons inside of it. If I have a dock panel with a background equals red, well, I know that's, hey, the dock panel, that was an object, I create that. The background red, that's a property set, I go ahead and set that. That's great. But then I go create this button, I know how to create that. This button here, I know how to create that too. What do I do with those things? Now I've got three objects wired in the world, but how do I relate those things? So one thing that we've added as metadata to .NET types is an attribute called content property. So you go ahead on your class and say something like content property, and you go ahead and in the dock panel's case, it has a property named children. And so we go ahead and define on your definition of the class dock panel. It's actually done at the base class of that panel. That children is the property. So now when we go back to this dock panel dock panel with two buttons inside of it, we know that these guys should be added to the children property of the dock panel.
Right.
And we basically understand a few different types of collection properties. It's either a singular property, a value that can take one value, or it's a plural, it's a collection of some sort. If it's singular, having two children, that's forbidden. We will give you an error if you do that. If it's plural, it's either got to be an iList, an iDictionary, or an array.
Right.
And we'll go ahead and add, call iList.add, call iDictionary.add with a key, all those kind of things.
And so that's kind of like a shorthand for having a dock panel .children as a child element here of the dock panel object here, right?
Sure. Yeah. Let's go ahead and just show what that would be. If I took this dock panel and the fully verbose form of that, and this still works, I just don't recommend that people do it, is you can go ahead and say dock panel.children. And so here's another case of having a period inside of a XAML, here inside of an element name. So here, dock panel, that's an object element because it instantiates an object. And dock panel.children, this is a property element because it's going to help you set a property. or add a number of things to a property, that's a collection.
Right.
So
when would you do that? Why would you do that?
well, we've made it so that in the common cases where we can say, oh yes, a linear gradient brush, it's got gradient stops inside of it. So, hey, I know if I go put an object inside there, should be a gradient stop.
Right.
We've made it so the default cases don't require that extra property element.
Got it.
But there's cases where you do want to go ahead and set, instead of background equals red, I want to go ahead and use a radial gradient brush and set a bunch of complex things about that radial gradient brush. So you could go ahead and effectively, under that dock panel, you'd say dock panel dot background, and inside of there you'd say radial gradient brush, and inside of there you do a bunch of gradient stops, and you set a bunch of properties here. You use the full power of XML to have rich structure to go ahead and set something like the background property. Now there's controversy over...
Yeah, so I was going to say that.
There's controversy over, well, couldn't you just extend this background equals red to go ahead and do something like background equals horizontal gradient space blue space red?
For example, to pick a random syntax
Just to
out of the air. Did we used to have anything like that, Rob, in the previous version?
Oh, we used to have a lot of that. Yeah. We used to have CSS support.
Well, doesn't it come down to the age-old argument of attributes versus elements, right? You could say radial gradient brush as a property, as an attribute.
Yeah. So when you get major nesting and a lot of information, then it gets harder and harder to do that as an attribute. So what we do is we use type converters. When you set things as attributes, we use type converters. So background equals red. We'll go look for the type of the background property, which is of type brush. We'll look at two places. We'll first look at the property and say, well, do you have a type converter attribute on you? And, well, no, most of the time you don't. But then we'll go look at the type itself, brush, and find out that there's a brush converter. And the brush converter owns what the syntax does. So, yes, we could invent very wild syntaxes for a variety of things inside of there. In our first version, we've tried to keep, conservatively, we've tried to limit the complexity there because it's more difficult to tool some of those things. So we were trying to limit the ways you can do things. We're all in favor of type converters when it can be somewhat simple, but when it leads somebody down a dead-end road, or basically it takes a large investment to go make an investment in lots of these little mini languages. So we've just tried to be conservative for simple ones. Now, if you go look at path data, we've got a pretty complex one there, but that's been invented before, and we've just kind of enhanced it.
Right, and that's kind of like pretty much the SVG kind of.
I think it was Microsoft's VML, I believe, at first, and then SVG as well. I think it's got both of those histories.
So something like a radial gradient brush, we've sacrificed a little bit of sort of ease of typing for the sake of a clearer, more toolable model that is something that can be more parsed than would otherwise be.
It's been a continual battle for us to figure out how important is Notepad.
Right.
And readability and writability. I've got a blog post from a year or two ago, like our 7 goals for XAML, and one of those things is human writable, human readable. I think we've balanced toolability with readability, writability.
Right.
So we'd love to hear what customers think of our choices so far. We'd love to see the tools ecosystem make it so that you're not going to be doing radial gradient brushes in Notepad.
Right.
Well, let's talk about that. Let's be honest. Isn't the ultimate goal eventually such that I'm never, as a developer, having to write XAML?
Wouldn't
that be nice?
Yeah. We shouldn't make people learn this markup language.
Yeah.
I think it's great that people can go see it, understand it, change it, but they shouldn't have to start there. We should have great visual designers like Expression, like Cider, that make it possible to go ahead and do things without knowing about this format. But sometimes, hey, it's going to take me 20 steps inside of a tool where I could go do a search and replace in the XAML, and I'm going to be more productive because it's in an XML format. I can grok it, I can change it, and I've got that power. So
we've not stopped using HTML just because there are good web design tools out there, right? So we need a model that is at least human readable and ideally human writable as well.
Absolutely.
So I'm conscious we're running out of time, and there are a bunch of questions I would love to ask. Perhaps we'll do a part 2. But one thing in particular I just want to kind of close off is a bit of a look sort of in the crystal ball, if you like. So, I'm just thinking of some of the announcements that are coming on stream now about Link and some of the kind of directions that we're kind of taking moving forward. I'm interested to see what you think we might do to XAML in V2. Where do you see your kind of investments being as we move forward?
Right. So XAML, I hope that it picks up more momentum. Well, first of all, serves WPF development in a great way, but also picks up more momentum in other fields. So there's a bunch of things that other groups that are interested in using XAML, and we just need to go ahead and do one more little thing to support their scenario. So we need to balance enhancing the WPF ecosystem and also just making general language investments that make it more multi-purpose. We need to look at all the different subsets of XAML presentation, our XAML P, our subset of our Avalon use of subset of XAML. We need to look at how XPS is using it. We need to look at how Workflow is using it. We need to look at how WPFE is using XAML and make sure we grow to meet their needs. There's a bunch of things that we want to improve as far as make the compiler better, make it just a more rigorous language, and provide additional services so that you can model new and different things. We'd love to see people represent data in a nice little form that is human readable, writable, and we want to explore that area. So there should be a number of interesting things.
Excellent.
Cool. All right, it's been great to chat with you, Rob. Thank you for your time, and perhaps we'll come back and do this again in a little while and see how things are going.
Yeah, let's see what the changes are.
Yeah.
Yeah.
Great stuff.
Great. Thank you
Thanks
very
a lot.
much.
Thank you.